Hi Princeton Tigers. Today we're going to continue reviewing perfect squares and perfect cubes. So for the first part of the guided notes, a number square means that you multiply the number by what goes in that blank? Right, itself. So when you multiply a number by itself, like you would when finding the what of a square, like you would when finding the area of a square, which is why it's called squared. For example, 5 squared equals what? 5 times 5. How can we write this in exponential notation? 5 to what power? Right, 5 squared, or 5 to the second power, which equals 25. So the two questions say write 4 squared in 3 ways. I'm going to do the first one, then you're going to do the second one on your own. 4 squared can be written as 4 times 4. So we're multiplying it by ourselves 2 times. How can we write 4 times 4 in exponential notation? Write it as 4 to the second power, which is the same as 16. Go ahead, write 6 squared in 3 different ways. Part 2, perfect squares. So a perfect square is a number that can be written as another number squared. For example, 16 is a perfect square because it can be written as what number squared? Right, as 4 squared. 4 squared is the same as 4 times 4. Now let's go through the example problems together. First, give me 3 examples of perfect squares. What are 3 examples of numbers that are perfect squares? We already did one, 16, because 16 equals 4 times 4. Another example that we usually forget about is 1, because 1 can be written as 1 times 1. Find 2 more examples and add them to that problem. The second problem says which of the following are perfect squares. I'm going to look at my worksheet from yesterday or at the back of the worksheet today, because all of those are examples of perfect squares. So 64 is a perfect square because it can be written as 8 times 8. Is 66 a perfect square? Nope. 49 is a perfect square because it can be written as 7 times 7. So A and C. 21 is not a perfect square because it can't be written as 2 numbers multiplied by themselves. Now let's look at the next one below, which says we do. Which of those numbers are perfect squares? These numbers are actually exactly the same as the first problem, so you can just skip it and go on and do the you do problem. So you just have one more problem to do because those are identical as well. Just make sure that when you're going through, you're checking to see if those numbers can be written as any number multiplied by itself. Alright, the last thing I want to go over is when you're doing the back of this page, something that we're struggling with is numbers cubed. We've gotten really good at doing the numbers squared, but when we get to the numbers cubed, we're having a little bit of trouble. If you don't know how to do this, you can definitely use a calculator to help you. All you're doing is you're multiplying this number by itself 3 times. But is 1 times 1 times 1 going to equal 3? No, because we start by multiplying the first 2 numbers, 1 times 1, and then we multiply it by 1 again, which is going to give us 1. I want to do one more. 2 times 2 times 2. Will 2 times 2 times 2 give us 6? No, it won't, because we need to start again by just multiplying 2 times 2, which is 4, and then times 2 again, which is 8. So 2 times 2 times 2 equals 8. If you're having trouble when the numbers get bigger, just plug them into your calculator. Plug in 3 times 3 times 3 into your calculator, and then try and solve it from there. And that will help you get the right answer, because you guys know how to expand it, but we're having trouble getting the right answer when we solve it. Alright, so finish up all of the problems on the back. If you can get started on the guided practice, go ahead and do that. And then we're going to be learning how to do square roots together at the end of class. Good luck.